The internet just exploded with two new humanoid robot videos that have everyone talking. And honestly, they deserve the hype. Tesla dropped fresh footage of the new Optimus Gen 3 showing off martial arts style moves that actually look smooth this time, while Unitree's upgraded G1 is out here getting shoved, kicked, and bouncing right back like it's built to take punishment. Both look incredibly real, both look next level, and both reveal a lot about where humanoid robotics is heading. So, let's put them side by side, breaking down what these viral clips really show, how far each robot has come, and what each one can truly do today. By the end, you'll know exactly which one seems to hold the upper hand, and maybe you'll disagree with me too. Tesla's latest Optimus demo looked closer to real time than ever before. No obvious speed ups, no overly polished edits. The robot mirrored a human partner, shifted into a defensive stance, and started reacting to attacks with visible coordination between its torso and legs. Not perfect, but noticeably more natural. Its balance corrections were small, its steps intentional. This wasn't just motion playback, it was AI-driven movement generated live from sensor input. That's a massive step. It means Optimus isn't just repeating programmed actions, it's analyzing motion data and deciding how to respond. The sequence started simple, with small shifts and cautious footwork, then built up into full body defense and counter movement. For the first time, Optimus looked like it understood rhythm and weight transfer, an actual sense of timing. Tesla still didn't highlight much hand dexterity. The fingers stayed fairly rigid, suggesting the rumored 22 degrees of freedom upgrade is still being integrated. But compared to earlier, stiff versions of the robot, this new footage showed control, confidence, and a surprising level of smoothness. Meanwhile, Unitree took a totally different approach. Their G1 wasn't trying to look graceful, it was proving toughness. Engineers pushed it, kicked it, even knocked it down hard, and the robot just kept standing up again and again. They called it anti-gravity mode. Not literal, of course, but the effect was impressive. Before hitting the ground, G1 repositioned its body, rolled through the fall, and recovered in seconds, pure instinct in machine form. That kind of recovery isn't luck, it's deep control. The G1 is packed with sensors, depth cameras, lidar, torque detectors across the joints, all feeding a predictive system that figures out how to brace and absorb impacts instead of locking up. That's why its movements look organic. Knees bend, hips shift, weight distributes dynamically, just like an athlete reacting in real time. In industrial and field environments, that resilience is everything. Robots don't fail because they're not smart, they fail because they can't handle unexpected motion or imbalance. A single fall can mean downtime or repairs. The G1's ability to self-recover so fast is an engineering win, and with a price tag around $16K, it's actually within reach for research labs and startups. Tesla's mission, though, is a whole different scale. Elon Musk wants thousands of Optimus units inside Tesla factories by late 2025. The plan: build around 5,000 this year for internal testing, ramp up to 50,000 within a year or two. If they can even hit part of that target, costs could drop fast, turning humanoids from prototypes into production workers. But humanoids aren't cars. You can mass-produce frames, not coordination. Reliability, dexterity, and safety take longer to mature. Optimus is evolving quickly, but it's still mostly a demo bot under controlled conditions. Unitree doesn't have Tesla's manufacturing muscle, but it has experience in the field. They've already shipped thousands of quadruped robots worldwide for defense, research, and inspection. That real-world feedback loop is how they hardened the G3 by breaking, fixing, and upgrading until it survives almost anything. It's not glamorous, but it works. It's how robots grow up. There's a darker twist, though. Recently, security researchers found a major Bluetooth flaw in some Unitree robots that allowed remote access and potential cross-infection between units. A walking botnet, every engineer's nightmare. And on top of that, telemetry was reportedly being sent back to servers in China every few minutes. Unitree promised to patch it and tighten security, but it raised legitimate concerns about trust and data privacy. Still, software vulnerabilities can be fixed, physics can't. And in that department, G1 looks physically stronger right now. The way it absorbs impacts, how it rolls, how fast it stabilizes, those are the traits that count in unpredictable environments. Tesla's Optimus is becoming more coordinated, yes, but it still moves like something trained for a stage, not a warehouse. The G1 already looks like it's ready for the floor. Beyond the robots themselves, there's a bigger race playing out, one between ecosystems. Tesla represents the tightly integrated American model, closed-loop hardware and software built around a single AI core. Unitree embodies the fast, iterating Chinese model, open, cost-driven, and constantly improving through feedback. One values polish and precision, the other thrives on speed and volume. The US refines in private, China evolves in public. And it's not just Tesla versus Unitree anymore. Meta's now entering the field with its own open AI-based Metabot, while Amazon's Frontier AI team is testing a framework called Omni, retarget that lets humanoids copy human motion from short video clips. In fact, they've already trained a G1 to do parkour and carry boxes just by watching a few examples. That's what makes the G1 so appealing. It's become a platform. Researchers, startups, and major tech firms can build on it, experiment, and push its limits without starting from scratch. Tesla's Optimus, meanwhile, lives inside a tightly controlled ecosystem built on Tesla's vehicle AI backbone. Cameras, vision systems, and reinforcement learning all connected through one massive data pipeline. If that network scales, it could give Tesla unmatched perception and decision-making capabilities. But the same thing that makes Tesla strong, its closed system, could also slow collaboration. While Unitree's openness invites global developers to experiment, Tesla keeps everything in-house, betting on refinement over chaos. Still, both face the same next big hurdle at hand: true dexterity, grasping tools, handling fragile parts, manipulating cables. Those are the benchmarks that separate a humanoid demo from a humanoid worker. Optimus hasn't nailed that yet, and G1's demo avoided it too. For now, it's all about movement and balance, because without that foundation, nothing else matters. Tesla's focus remains on control and precision, mastering coordination before chasing complexity. Unitree, on the other hand, keeps proving its robot can survive whatever chaos the world throws at it. It's brains versus grit, elegance versus endurance, and right now, those differences define how each company sees the future of humanoids. Tesla's approach is long-term. Musk isn't just building a robot, he's designing a worker that can operate safely around humans in Tesla's own factories. That means controlled testing, slow rollout, and gradual improvements in AI decision-making. Every movement Optimus learns today could translate to more autonomous factory operations tomorrow. It's a strategic build-up, turning human skills into machine muscle through repetition and simulation. Unitree's approach is faster, rougher, and more public. The company tests its robots in every possible condition: slippery floors, uneven terrain, direct impacts, and then refines what breaks. That's why its hardware evolves so quickly. It's not just about looking smooth, it's about being unstoppable. Each version learns resilience the hard way, and that gives Unitree an edge in durability. Both philosophies are valid, but the contrast couldn't be sharper. Tesla wants perfect coordination before deployment. Unitree wants deployment to create perfection. The result: Optimus moves like a dancer rehearsing, G1 moves like a soldier adapting. One focuses on grace, the other on grit. Yet there's another layer emerging: collaboration. Meta's open AI frameworks, Amazon's control systems, even Google's robotics initiatives, all of them could eventually plug into existing humanoid bodies. And that's where the open design of Unitree's G1 might start to dominate. Its flexibility lets researchers use it as a testbed for entirely new AI brains. Tesla's Optimus, while incredibly advanced, remains locked behind the Tesla ecosystem, making external experimentation much harder. Still, if Tesla's integration between cars, cameras, and robots truly connects into a single data network, it could create something revolutionary: a shared intelligence system where every robot learns from millions of real-world interactions gathered by Tesla vehicles and machines. That's the kind of data scale no one else can match. Meanwhile, Unitree's momentum comes from sheer accessibility. Its robots are in labs, universities, and startups worldwide, learning from chaos, failure, and field use. That distributed growth gives it diversity in training environments Tesla's lab testing can't replicate. And while both companies are refining movement and control, the next real leap might come from context awareness. How robots understand the world around them. Seeing a human gesture, predicting a task, interpreting intent, those are the challenges that separate automation from autonomy. Right now, Optimus seems to be learning structured intelligence as responding to input, mirroring, adjusting balance with cognitive precision. G1 seems to be learning instinctual intelligence reacting, recovering, surviving through adaptive motion. The difference feels almost biological. One learns through logic, the other through pain. As competition heats up, that divide might decide who dominates the humanoid market. Tesla has vision and infrastructure. Unitree has agility and openness. One is playing a long game of refinement, the other is sprinting through evolution, and that sprint is forcing everyone else to move faster. Every new clip from Unitree feels like a challenge thrown directly at Tesla, a reminder that progress doesn't always for perfection. When a robot can take a hit, roll, and stand up again in seconds, it suddenly feels less like a prototype and more like a product that's ready to work. Inside Tesla, though, there's a different kind of urgency. Optimus isn't just about showing off movement, it's about integrating robotics into Tesla's entire AI ecosystem. The same neural networks that interpret camera feeds in Tesla cars are being adapted to teach the robot how to perceive its surroundings. Every frame of footage from millions of vehicles becomes potential training data for the robot's brain. It's an ecosystem where vision, motion, and decision-making all evolve together. That's what gives Tesla an advantage no other robotics company has right now: scale. But scale also brings pressure. The closer Optimus gets to production, the more people expect it to do real work, carrying parts, sorting materials, maybe even handling basic assembly. Those are not cinematic tasks, they're hard, repetitive, and full of unpredictable variables. The question isn't whether Optimus can move like a human anymore. It's whether it can work like one, day after day, without breaking down or losing coordination. Meanwhile, Unitree is taking a very different route to market. Instead of chasing a single grand vision, it's flooding the world with small, practical steps, selling to researchers, defense teams, logistics firms, anyone who wants a humanoid platform to test. Every deployment becomes a free stress test, every bug report another data point for improvement. It's fast, messy, and brutally efficient. That's why the G1 evolves in months, not years, and that pace is shaking up the industry. Other players, from Boston Dynamics to Agility Robotics, are watching how Unitree's open hardware is being adapted for projects worldwide. Some labs are training G1s for rescue operations, others for warehouse automation. The robot's versatility makes it a blank canvas, a body waiting for whatever brain someone wants to install. Tesla's Optimus, on the other hand, is more like a fortress. Sophisticated, elegant, but isolated. Its power comes from integration, not openness, and that creates a fascinating tension between two philosophies of innovation: build one perfect system or build 1,000 imperfect ones and let evolution decide which survives. The more you look at it, the clearer the pattern becomes. Tesla is teaching its robots why to move. Unitree is teaching its robots how to move. Tesla's intelligence grows from structured learning. Unitree's strength grows from chaos. Both are right in their own way, and both are driving robotics into an era where motion and thought start to blur together. And as those lines blur, the real question isn't who wins this round. It's who defines the next one. Tesla's Optimus Gen 3 represents the dream of intelligent precision, a future where machines understand tasks, plan ahead, and move with human-level grace. Unitree's G1 represents the power of survival, a future where machines don't freeze, don't fail, and keep getting stronger with every iteration. Optimus is the strategist, deliberate, methodical, learning the rules before breaking them. G1 is the fighter, relentless, adaptable, built to take hits and keep standing. Both are rewriting what it means for robots to be alive in a world built for humans. In the end, this isn't just about two humanoids trading viral clips. It's about two entire ecosystems competing for the soul of the robotics era. The US refines intelligence, China accelerates evolution. One is building smarter robots, the other is building more of them. And somewhere between those extremes lies the version of the future we'll all be living in, because progress doesn't always look perfect. Sometimes it looks like a machine learning to fall, to rise, to move forward again and again, until one day it doesn't need to anymore. Thanks for watching. Share your thoughts below. Hit like if you enjoyed this breakdown and catch you in the next one.